Hello, guys. Hello, Nihal. You okay? You're the first one who is joining. Oh, thank you, Nihal. I think people are watching match. I put wrong timing. It's a Euro Cup, Nihal. Okay, let's wait for 5 minutes. If people join, then we can start. Otherwise, hi Rohan. I think people are watching match. Okay, let's start. Let people join. We can start now. So, what I'm going to do, I'm just going to share my screen. Okay, so if you see question on my OneNote, so first question is, if you can read it, yeah. So a heavy suitcase S. So this is suitcase here. It is S. Mass 50 kg. Mass 50 kg. It means its weight is acting down. That is 50 times G. Moving along a horizontal floor under the action of a force. So this suitcase is moving in this direction, right? In this direction. Okay. And S moves in a straight line at constant speed. Speed is constant here. And then suitcase is modeled as a particle and the floor as a rough horizontal plane. The coefficient of the friction between S and the floor is 3 over 5. So coefficient of friction is given. So coefficient of friction is always opposed the motion of the force. So if force is in this direction, yeah, so friction will be applying in this direction, right? So this is your frictional force, right? So I have written here FR, frictional force. It is in this direction and it is moving in this direction. Okay, so and this angle is given 30 degree. Now, if you extend this line, okay, and this line extend, so this is also 30 degree, right? So, and they are saying there's a P force acting in this direction, yeah. So this direction, if you see here, it is given P Newton. So P is here and 30. So its horizontal component will be P cos 30, and its vertical component here in this direction, we can write down P sin 30. And this 50G, okay, so this 50G is balanced by a reaction R. Okay, so let's draw reaction R here. Okay, so I have divided all my component. So first of all, let's write down, let's balance this. So this R capital R, this R, reaction R, must be balanced by 50G and plus P sine 30. Upward force equal to downward force. So R equal to, we can write down 50G plus P sine 30. That is our equation 1. Okay. Now, this frictional force F will be balanced by P cos 30, left hand force equal to right hand force. So, this frictional force FR equal to P cos 30. So, let's write down here P cos 30 degree. That is equation 2. Now, we know F equal to mu times R. Mu is coefficient of friction, R is reaction, and F is frictional force. Okay. So this we can write down mu times R. So mu R equal to P cos 30 degree. Okay. This is basically 9 marks question, guys. So mu, what is R? We know R is 50G plus P sine 30. Yeah. So this R, we can keep it here. So it should be 50G plus P sine 30 equal to P cos 30. Okay. So let's, and our coefficient of friction is given here 3 over 5. So that is mu. Mu is 3 over 5. So let's write down here 3 over 5. And it is 50G plus P sine 30. Sine 30 is 1 by 2 P, and cos 30 is root 3 over 2. From here, we can simplify it. If you multiply inside, so it should be 30G. I have divided by 5, 5 times 10, and it is 30G. And it should be 3P. Okay. So it should be 3P over 10. And this should be P root 3 over 2. Right. So this is what we got it. Now, from here, if you work it out, so it should be 30 times G. G is 9.8, and you can write down P root 3 over 2 minus 3P over 10. And from here, once you work it out, your P will be 520 Newton. You put this value in a calculator and you will get P is 520 Newton. Okay. So is that okay? So if you can write down in the comment section and just let me know. Okay. So Kevin, it is clear. You joined late, Kevin. Yes. How can I do, Kevin? Just let me know. Just write down in a chat and I will do that. Okay. Let me see. Kevin, you can let me know and I will. I can do that. Yeah. Okay. That's fine. So okay. Thank you, Sahar. You have also joined late, Sahar. Okay, so first question I have, do you, Sahar, do you want me to explain first question again? Or is it clear? Here it is, first question. Okay, you can go over the video because it is recording, so you can go over. Now, next question we are going to do. Let's start with the easy question here. So I have arranged all the question in a line. So, yeah. So if you see, it's a basically a concept. If here is a particle, right? And there is a force here, 35 Newton. Okay. And this is 17 Newton here. Okay. And this is 25 Newton here. And these are the vertical component here. And this is horizontal component, we'll find out here. And this angle is given 55 degree. Right, 55 degree. So how we are going to form a equation? This is not a question, we are just, I've taken example from my side. So see here, it is 35 and this is 50. So in this direction, see where my black line is, it should be 35 cos, it is 55 here, so it should be cos here, 35 cos 55, and this side it should be 35 sine 55. Okay. Now, if we take 25 degree, so 25 degree, it is 55, and suppose it is given 25 degree here, right? So in this direction, it should be 25 cos 25 degree, and in this direction, I'm put green arrow here, it should be 25 sine 25. This is the way we divide the horizontal and vertical component. And once we are balancing left hand force equal to right hand force, and upward force equal to downward force. So left hand force, if you see here, it is 17 Newton. So 17 Newton must be balanced by these two forces, 25 sine 25 and plus 35 sine 55. They both are working on horizontally. So this we can write down 25 sine 25 and plus 35 sine 55. This is the way we divide the component. And then upward force component, it is 35 cos 55. If you see here, 35 cos 55. So 35 cos 55, and that will be balanced by 25 cos 25. So we always balance. This is the way. Okay. Now, if there is another particle, this is the concept we are going to use today. So this is the concept, horizontal component and vertical component. If question is like this, suppose this is a particle here, and here we are applying force F, right? Force F, and here it is at an angle theta. So definitely in this direction it should be F cos theta, and in this direction it should be F sine theta. Okay, and why it is F cos theta here? So you know SOHCAHTOA, it is theta, it is F. So this direction, if you apply SOHCAHTOA, it should be F cos theta, and this should be F sine theta. Okay, so that's what we have done. And here it's another force is 26.5 Newton, and this side here it is 40 Newton. Okay, so in this case we need to find F. Okay, so let's balance horizontal force equal to horizontal force left hand side and right hand side. So see here, here it is 40 Newton, it is F cos theta. So we can write down here F cos theta equal to 40. Okay, that is equation 1. And vertical and downward, so F sine theta equal to 26.5. Okay, 26.5. Now F and F will be cancelled. Yeah, and 20 over and cos theta over sine theta, it should be cot theta. And if cot theta equal to 40 over 26.5, and you flip both sides, so we'll get 10 theta equal to 26.5 over 40, and from here we can find theta. Okay, and that will be given by theta equal to 10 inverse 26.5 over 40, and this your calculator will give you. Okay, so let's go through the exam questions now. So my first exam question which I'm going to solve, here it is. This is the question. So I'll just make it big so that you can read it carefully. So see here. Here it is a vertical rope PQ. So this is our vertical rope PQ with red line. PQ has its end Q attached to the top of a small lift cage. So this big one is lift cage, and the lift cage has mass 40 kg. So lift has mass 40 kg. So we are writing here 40 G is acting down. I've not written in the middle because there is a box here, and carries a block of mass 10 kg. So this is your 10 kg. This is your 10 kg. So 10 G is also acting down as shown in this figure 1. The lift cage is raised vertically. So it means acceleration is working upward vertically by moving the end P of the rope vertically upwards with constant acceleration 0.2. So acceleration is 0.2. The rope is modeled as being light and inextensible, and air resistance is ignored. Using the model, find the tension in the rope PQ. So this you need to find tension in the rope PQ. So how we are going to do it? Just see here. So first of all, tension will be acting upward. So T. So we know Newton's second law of motion, F equal to mass times acceleration, right? So tension is, because it is going up, so T will be more than 10 g and 40 g. So it should be T minus 10 g plus 40 g, because their combined force is acting down, that is 50 g. So their resultant T minus 50 g is acting up, and this is your force. Force is mass times acceleration. How much is the mass here? So mass is 40 plus 10 is 50. Remember, you no need to put g. With mass, g doesn't come. With weight, g comes. And acceleration is given 0.2. Okay, so this should be T minus 50 g equal to 50 times 2, it should be 10. Now, so it should be T equal to 10 plus 50 g, and g is 9.8. So 50 times 9.8, if you put it in a calculator, then it is coming 500 newton tension. That ends the first part. Find the tension in the rope. So tension is 500 newton. So guys, is it clear, or anybody wants? Welcome, Monil. Okay, is there anyone you want me to go over again? Okay. Okay, thank you, Inaya. So that's done. Now we are going for its second part. Find the magnitude of the force exerted on the block by the lift cage. So see here. Here I'm writing force exerted on the block by the lift. On the block by the lift. Okay, this is what. So see here. Reaction. Here reaction, let me change the ink. So if let me use this one. Okay, a reaction of this box is R, and 10g is acting down. Yeah, so R minus 10g, this will work as a force, right? Equal to mass times acceleration, that is 10, and acceleration will be same because lift is going upward. So 10 into 0.2. So R equal to 10g plus 10 times 0.2 is 2, and if you simplify, it should be 100 newton. So that ends our part B. Okay, they both are 3 marks question. It is past exam question. Any any doubt, guys? Please write down in a chat box. Okay, why it would not be 50 gram? So thank you, Rohan. So if you see here, why it is not 50 gram? Because if you see force exerted on the block by the lift, so we are considering block here, not the lift, Rohan. Is that okay? We are read the question. Rohan, did I answer your question? Okay, thank you. Thank you. These small details. Yes, in a lift has no effect. Lift's acceleration we are using. Lift is going up, so lift's acceleration we are using. Okay, thank you, Rohan. Okay, okay. Now didn't is coming. Okay, thank you. So now next question, very important question. You might get this type of question in mechanics paper. So this is police question. Yeah, either pulley will be there or inclined will be there. One of them will be there in the exam. So I'm just making it big so that you can read it the first half part, and then I'll make it a small. Here it is written, a ball p of mass 2m is attached to one end of the string. So this is 2m. Okay, this ball is attached here, and the other end as the of the string is attached to the ball q of mass 5m. The string pass over a fixed pulley. The system is held at rest. So this is important, right? So system is held at rest with the balls hanging freely and string taut. The hanging parts of the string are vertical with p at height 2h. So this height is given 2h. Okay, and this height is given h. Okay, horizontal ground with q at height h above the shown above as shown in the figure. Now, second part, what they are saying here. So the system is released from the rest now. System is released from the rest. So when system is released from the rest, which weight is heavy here? 2m or 5m? Guys, which weight is heavy? Yes, if you are writing 5m, then it is fine. So definitely, when it is released, it is going down. Acceleration is working down. Okay, and balls are modeled as particles. The string is modeled as being light inextensible, and the pulley is modeled as being small and smooth. Air resistance is modeled as being negligible. Using this model, write down the equation of motion for P and Q. So they are asking, write down this model, equation of motion for P and equation for motion for Q. This is what we need to write down. So we require diagram here. So once we require diagram, just have a look what is happening. So let's write down here. So this is 5. So 5 mg is working down. Here 2 mg is working down. Tension is working up, and pulley is applying tension down as well. That we are not considering at the moment. Okay. So first let's consider this one. So this one, this weight is more. So 5 mg will be more. So 5 mg minus t, that is the resultant. So that should be equal to F equal to mass times acceleration. So this is our F equal to mass. What is mass here? It is 5m and acceleration is A. That is first part. Okay. And what will be the equation of Q? Because this is going up. So here tension will be more than 2 mg. So we can write down here T minus 2 mg equal to 2ma. That is your second equation. Okay. And we can simplify it, but they are asking you to find the tension, find the equation. So this is first part and this is second part. Now let me see what they are asking you. Second thing, they are saying this first I and II we have done. Then they are saying find in terms of height only the height above the ground at which P first comes to instantaneous rest. Instantaneous rest means at particular time it is getting at rest. Okay, so let's do this part now. uh, 5 mg and this. So let's solve simultaneously these equation first. Okay, so once we'll solve, so let's draw a line. So I'm just solving it my way. Minus t and plus t is cancelled. 5 mg minus 2 mg is 3 mg, and 5 ma plus 2 ma is 7 ma. M and m will be cancelled out. So we got 3g equal to 7a. So acceleration we got 3g over 7. Okay, this is our acceleration. Right now, let's read next line. So Q is going down. When Q is going down, then Q is going to hit it here at the ground level. If it is hitting at the ground level, what will be the velocity at the time of hitting, and what will be the time, how much time it will take? So V and T we need to focus. So let's write down velocity with which it is hitting the ground. So we are considering now velocity with which it is. I'm writing this for you, so when you are watching this video later on, it should be clear. On the ground, on the ground. So we apply, see, height is involved, initial velocity u is 0. Yeah. We need to find. U is 0, acceleration is 3g over 7, and displacement s is given height. So all these things comes in v square equal to u square plus 2gh. Yeah. Okay. Or acceleration is here a. Let's write down 2as. V square, let's cancel it, write down, I have written in a gravity form. V square equal to u square plus 2as. Okay. So u will be 0 plus 2. Acceleration is 3g over 7. And s is height h. Okay. So we got 2 times 3, 6gh over 7. Okay. 6gh over 7. So our v will be square root 6 gh over 7. With this velocity, it is going to hit the ground. Now, when it is going down, then P is going up. Okay. When Q is going down, okay. So when Q is going down, then P is going up. Sorry about that. So I scrolled too much. Okay. So here it is. Yeah. So see my reading. When Q is going down, down, then P is going up because P has less weight. Okay. So when P is going up, so at certain point when P is coming at rest, at that point velocity will be zero. Yeah, when P is coming at rest, okay, then velocity will be zero, and we are going against the gravity, so A will be minus G, right? So let's apply here. Okay, so I'm just creating a space here so that we can see the diagram as well. Okay, so here acceleration we are using minus G, and velocity, with the same velocity it is going up. So we have just found velocity is square root 6 gh over 7. Okay, so we will use the same velocity here, uh, square root 6 gh over 7. Okay, so velocity we will use 6 gh over 7. I will read the comment. Let me finish the question. And then v square equal to u square plus 2gh. Acceleration is negative, so we can put here minus sign. Okay. At certain point, v will be 0 here, and u is u square. So square root of 6gh over 7, we can write down 6gh over 7. Okay, and minus 2g, suppose it goes until height h here. So this h I have replaced with h, so it means 6gh over 7 equal to 2g capital H. G and g will be cancelled out, so we got h equal to and this 2 times 3 is 6, so h equal to 3h over 7. And this is what they are asking. If you see here, uh, find in terms of small h, okay, the height above the ground at which P comes to the instantaneous rest. So that's why we have put V equal to 0. Okay, now I'm going in a comment section and let me see. Okay, guys. Yes, Kevin. Definitely, I will try to do year two stats tomorrow. Yeah. When is your paper? Write down the date. It is 24th or Friday, Kevin. Thursday. Okay, Thursday. So we have tomorrow. Okay, Thursday 25. So we have tomorrow. Okay, so tomorrow we will do, but it will be a late around 8:30 or 9 o'clock. Is that okay, Kevin? Sahar, I will definitely do stats. Okay, that's fine. Okay, that's fine. Okay, thank you, Rohan. So here, let's go back to the question. So we have done C part, B part as well. Now, then C part, this question will be there in the exam. State one limitation of the modeling the ball as particle that could affect your answer to part B. So you can say the distance that Q falls will not be exactly height h. Okay. So for C part, here you can see the distance, okay, that Q falls will not be exactly h, will not be exactly h. Okay, and D part state how this would affect the acceleration of the particle. Okay, so there are many answers. This is 1 marks question, so one comment will be enough, but I can say, okay, uh, we use inextensible. Inextensible means acceleration throughout remains the same. So first of all, you can say it is inextensible string, and the acceleration of ball, okay, acceleration of ball will affect inextensible string. Okay, and here you can write down the acceleration. Let me write down, if you are not listening, acceleration of the ball. Okay, will not have equal magnitude. Will not have equal magnitude. Equal magnitude. Okay, so that is answer to D part. Is that okay, guys? Speed is okay. Okay, that's fine. So let's move forward. More questions. So this is another question here for pulley. Uh, I will give you 2 minutes. Just write down the equations for this. Okay. Please write down the equations. I can make it little big. Here it is. Please write down equations. Okay. Thank you. Those who are writing, please check your equations with my equation. So here 3 mg is acting down. 4 mg is also acting down. And one end of the string is attached to a small p of mass 4m. The other end of the string is attached to another small ball q of mass 3m. The string passes over a fixed pulley. The ball p is at rest and with the string taut and the hanging parts of the string vertical. Ball P is released. The string is modeled as being light and inextensible. They will definitely write it. And the pulley is modeled as being smooth and air resistance ignored. Using the model, find in terms of M and G the magnitude of the force exerted on the pulley. Guys, here magnitude of the force exerted on the pulley. Okay, they are not asking about these masses P and Q. They are asking, read question carefully, the magnitude of the force exerted on the pulley by the string. Okay, so let's write down tension will be here up, here tension will be up, right? And acceleration, because 4m is more, so acceleration is here down. So this, let's take this part. So here T will be less, T minus 3 mg equal to 3 ma. That is your equation 1 for this part. And for the this part here, mg is more. So 4 mg minus t equal to 4 ma. That is your second part. Okay. So if you want to cancel, you can cancel it, right? But they, again, I'm saying they are asking the force extended on the pulley. So on the pulley, there are forces here, whatever they are extending, that we need to find. So let's write down from equation 1. From equation 1, if you write down T equal to 3 mg, 3 mg plus 3 ma, right? 3 mg plus 3 ma. Okay. Now we require A. So what we can do, we can solve it. Once we solve it, we'll find A. So see, minus T plus T cancel. 3 mg and 4 mg, we can write down here 7 mg. And here it is 7 ma. M and M cancel. 7 and 7 cancel. So A, 1 minute. Did I write something? T minus 3 mg equal to 3 ma. And 4 mg minus T equal to 4 ma. Okay, so I did one mistake. Plus 4 mg and minus 3 mg, it should be 1 mg. Okay, and M and M cancel, so it should be G by 7. A is G by 7, and put A here, G by 7, you will get the tension. So tension is 3 mg plus 3m, and A is G over 7. So you can make the common denominator, and it should be 7 times 3 is 21, 21 plus 3, 24, 24 mg over 7. Okay. Now force on pulley, this question. Force on pulley, how much it is? Can you write down in the comment section? Force on pulley, guys. How much? Force on pulley? Okay. Yeah. It should be equal to 2t Inaya. Okay. Okay. That's fine. So, guys, if you'll write down the comments which is related to content, it will be very good. Okay. So now, so force on pulley is equal to 2t. Okay, so 2t, because one tension here and one tension here. So it should be 2, and t is 24 mg over 7. That is 48 mg over 7. So this will be your end of A part. Now, state the limitation of the model apart from ignoring and a resistance that will affect the accuracy of your answer to part A. So we can say weight of the rope. Weight of the rope. Okay, or you can say pulley may not be smooth here, or pulley may not be smooth. Okay. Okay, AR10, whoever it is, please do not write unnecessary comment. Yeah. Okay, otherwise we can ask Pratham who is AR10, and then we can speak to you tomorrow. Please do not write unnecessary comment because this is A level lesson. Okay, thank you guys. Now, next question. Okay, here is the next question. A particle P moves along a straight line. Okay, straight line such that at time t seconds, t is greater than 0, after leaving the point O on the line, the velocity v meter per second of P is modeled like this. So v equal to 7 minus 2t and t plus 2, that is equation 1. Okay, if you multiply this, it should be 7t plus 14 minus 2t square minus 4t. Okay, so let's write down, rearrange minus 2t square plus 3t and plus 14. Now they are saying find the value of the t instant when p stops accelerating. So acceleration is what? dv over dt. So we need to differentiate this. So we need to differentiate. So dv over dt, it should be minus 4t and plus 3. So, and then say, find the value of the t at instant when p stops. P stops means acceleration is 0. Acceleration is 0 means minus 4t plus 3 equal to 0. And we can find the value of t. T is 3 over 4. And one more thing, uh, they are saying find the distance of P from O at instant when P changes its direction of motion. Okay, so what we need to do, so our V is minus 2t square from here, minus 2t square plus 3t and plus 14. Okay, so V is ds over dt. Okay, so ds over dt is minus 2t square plus 3t plus 14. And if you integrate both sides, so s will be minus 2 t3 over 3 plus 3 t square over 2 and plus 14t. Okay, now we need to find the value of t here. So if you see, when it stops, so then v is also getting 0. So see my red ink. So from here, v is also getting 0. V is getting 0, it means 7 minus 2t and t plus 2, that should be equal to 0. So t is minus 2, which is impossible because t is given greater than 0. And here 7 equal to 2t and t equal to 3.5. Yeah. So t equal to 3.5. So if you put 3.5 here, replace t with 3.5 here in this equation, this asterisk sign one. So S will be, if you put minus 2, t is 3.5 to the power 3 over 3 plus 3, t square 3.5 is square over 2 plus 14, and t is 3.5. And if you put all these value in a calculator, it will be 931 over 24 or 38.79 meter. Okay, this ends the B part of the question. Okay, okay, guys, is that okay? Please write down. Okay, thank you. Thank you. Okay, that's fine. Thank you. Thank you, Sahel. Sahel, you joined late. Now I have seen your message. Okay, now next question we are moving. It is, you might get this type of question in the exam. So just see here. So this is another question. Questions are so big, it is very, very difficult to snip it and put it here. So if you see, this is your first part of the question. Have a good read. A small ball P of mass 0.8 kg is held at the rest on a smooth horizontal table. So it is here, and it is attached to one end of the thin rope. The rope passes over a pulley that is fixed at the edge of the table. The other end of the rope is attached another small ball Q of mass 0.6, that is here, and that hangs freely below the pulley. Ball P released from rest with the rope taut, with P at a distance of 1.5 meter from the pulley and with Q at a height 0.4 meter above the horizontal floor, as shown in the figure 1. Ball Q descends. Ball Q descent means this ball is going down, okay, and hits the floor and does not rebound. So this ball is going and hitting the floor here and does not rebound. The balls are modeled as particles, the rope as a light and extensible string, and the pulley as a small and smooth. So, using this model, then they are asking you to find, show that the acceleration of Q as it falls is 4.2 meter per second square. So, first we need to show acceleration. Okay. So, what we need to do, so see, I will write down here. So, you can see diagram. Okay. First of all, this distance is there, and we can put tension here and tension here, working on the string, and it is going down, descending. So acceleration is down, and this is 0.4 meter. Okay, and this will be 0.6 g down, and this is 0.8 kg. It is kept on the table. So first, this is going down. Acceleration is going down. So start from here. So 0.6 g minus t equal to mass times acceleration, that is 0.6 times a. Okay, that is your first equation. This is F equal to mass times acceleration. And top equation here, where I'm putting the red tick, it should be D equal to 0.8a. Right hand side equal to left hand side, 0.8a. That is the force we are having here. Now t is 0.8a, so you can put the value of t here in this equation. So 0.6 g, t is 0.8a, and it is 0.6a. Okay, so 0.6 g equal to 1.4a, and if you simplify, a is 0.6 g divided by 1.4, so it will be 4.2 meter per second square. Okay, that ends the first part. Okay, now when they are saying find the time taken by P to hit the pulley from the instant when P is released. Okay, so here P is released, right? P is released and then Q is going to hit there. So time, okay, so let's write down here. We need to find time. So we will apply this formula, S equal to UT plus half AT square. Okay, I'll explain you. Uh, so this distance is 0.4. So S is 0.4 meter because it is released from the rest. So 0 times t will be 0. It is half. Acceleration we have just found, it is 4.2, and t we need to find t square. So if you multiply, it should be 0.8 divided by 4.2, it is t square. And from here, if you find out t, it should be 0.43 second. Okay. Now, speed of q when it hits the floor. So this q, speed of q when it hits the floor, that we need to find. Okay. So let me change color. So speed of q when it hits the floor. So let's see how much time it is going to take to cover distance, sorry, displacement from here to here, right? Okay, from here to here. So if we apply v equal to u plus at, because we need to find time, right? So again, initial velocity is 0. We need to find the with the velocity with which it is hitting, and acceleration is 4.2 same, and time is, we have just found 0.43 second. So we can write down 0.43 second. Is that okay? So our velocity will be the 4.2 times 0.43, it should be 1.8. Okay, now one thing left, to find time for P to hit the pulley. Okay, now see here, when it is going down, this P is going to hit the pulley. Okay, P is going to hit the pulley. So in how much time this P is going to hit the pulley? This is what we need to find. Okay, so let's do it here uh, to find time. So let's suppose this time is T2, right? Okay, if it is this time is T2, so what we can do here, so if you see how much distance it has covered, guys, this is very important. So 0.4 meter it has already gone down, and how much it has gone this side. So we can say 1.5 minus 0.4, this much is the distance, because 0.4 meter it has already gone down. So how much is left? That is 1.1. Okay, and here also we are applying v equal to u plus a t2, right? So initial velocity will be 0. Okay, and t2 time we are finding, and v will be same here. So t2 will be uh, distance 1.5 minus 0.4, and if you divide it by v, and v is what, 1.8. So 1.1 divided by 1.8. Okay, so this should be 0.6. So total time from here, see my highlighted one, total time taken by this ball cue, this is from here to here, and this here to here, not fully pulley. No, this is not reaching up to the pulley. So 0.4, and this is 1.5 minus 0.4. So total time you can add it. So it should be T1 plus T2. So T1 plus T2. T1 we got already 0.43, and T2 is 0.6. So it should be 1.03 second. Okay. And last part, that is C part, state the limitation. This question, they will always ask, state the limitation of the model that will affect the accuracy of your answer. Guys, you can watch this video again if it is not clear. Yeah. So state one limitation. So you can say rope being light. This can be one answer. Rope being light. If you don't like this, you can write down another one. Rope being inextensible. Rope being inextensible. Okay, and even if you don't like this one, you can say pulley being smooth. Pulley being smooth. Is that okay? Is that okay? Yes, year 13. Year 13, please write down the comment. Uh, is it clear or should I explain again? Thank you, thank you, thank you, thank you, guys. That is enough. Yeah, thank you. Okay, now one more question. So I have collected varieties of question. Here it is. I don't know whether Amir is there or not. This was the question Amir asked. Okay, so I have kept it for him. So Amir, are you there? Okay, that's fine. He must be studying. It's okay. Okay, that's fine. Okay, now, so if you see here, we can make another diagram, right? So let's draw another diagram here so that, okay, this is, and this is x Newton, it is there. So I can extend it. Okay, this is x Newton here. Okay, this angle is alpha, and this is working down, it is 5g, and this will be your reaction r, and this will be alpha. So this should be 5g cos alpha. Okay, let me use red ink to differentiate. So this is 5g cos alpha, and this side down it should be 5g sin alpha. Okay, so a small block B of mass 5 kg is held in equilibrium on the plane by a horizontal force. The force acts in a vertical plane, which contains in a line of greater slope of this inclined plane. The block B is modeled as a particle. The magnitude of the normal reaction of the plane is 6.68.6. So R is already given 68.6 Newton. That is normal reaction. Okay, find the magnitude of the frictional force on B. Okay, and state the direction of the frictional force on B. This is what we need to find. Okay, so frictional force always oppose the motion. So if we extend this side, okay, and frictional, if it is going down, then frictional force will oppose the motion, it will be working up, and here this angle will be also alpha. Okay, so this red ink, here we can write down x cos alpha, and this side again we can write down x sine alpha. So you can see there are different colors, they are representing different components. Okay, okay, let's write down, find the magnitude of the frictional force on B. So let's balance the force. So R equal to this, R equal to x sine alpha plus 5g cos alpha. That is equation 1. Now let's balance the force toward the inclined, this one. Okay, this one was the reaction and this is towards the incline. So we can say F plus x cos alpha equal to 5g sin alpha. That is equation 2. Okay, now from equation 1, R is 68.6. Okay, so let's write down R is 68.6. So this is 68.6. X sine alpha, x we don't know, but sine alpha we can find out because 10 alpha is 3 over 4. So if it is alpha, this is 3, this is 4, then this will be 5. So x cos alpha is 4 over 5 here, and sine alpha is 3 over 5. Is that okay? So this what we can do it. So x sine alpha, so sine alpha is 3 over 5 plus 5g, and cos alpha is 4 over 5. Is that okay? Now, if you simplify it from here, so this should be, if you multiply by 5 here, it should be 343 equal to 3x plus 20g. Okay, 3x plus 20g. And from here, if you find out x will be 483 Newton. Put all these value in a calculator, you will get x equal to 483 Newton. Okay. Now, from second equation, here, f plus x cos alpha. So now we need to find f plus x. X is x cos alpha. X is 483 Newton, right? So sorry, for 48.3 Newton. So it should be 48.3. Okay, times cos alpha. Cos alpha is 4 over 5 equal to 5g. So 5 g is 9.8, and sine alpha is, if you see sine alpha is 3 over 5. So we can write down sine alpha is 3 over 5. Okay, so this 5 and 5 will be cancelled, and from here if you find out f value will be, so I'm just writing directly, we do not have that much space, so it should be f plus 38.64, and this should be 29.4. So f is 29.4 minus 38.64. It is coming negative, and negative 9.24 Newton means it is acting down. It is written here, find the magnitude of the frictional force acting on B. Okay, and state the direction, so it is acting down. This is what we have done. Is that okay? Now, then they are saying find the acceleration, right? Find the acceleration. So how we can find acceleration? So see, for B part here, find the acceleration. Okay, so it is saying, given that the coefficient of the friction between B and the plane is 0.5, find the acceleration B down the plane. So down the plane, so if we write down here f, second equation, f plus x cos alpha. Okay, so 5g, I'm taking f that side here. So 5g sine alpha minus f. Okay, that should be our resultant force, and that will be mass times acceleration. So mass is 5, so let's write down 5 times a we need to find. So 5g sine alpha is 3 over 5 minus f, and it is 5a. So 3g minus f equal to 5a. Okay, 3g minus f equal to 5a. So from here we can find out, this is your equation 2. Okay, and from here we can find the second equation. Just let me create the space, guys, because it is getting too congested, and let me clear this. 1 minute. There, I need to write down neatly. Okay, now it is clear. Okay, so here we can write down 5g sine alpha minus f equal to 5a. So this will be your equation 1, and write down the value. Sine alpha is 3 over 5 minus f equal to 5a. 5 and 5 cancel, so 3g minus f equal to 5a, right? And this 3g minus f, okay, 3g minus f, and the second one here, if you see, r is equal to 5g cos alpha. From here, r is 5g cos alpha, right? So r is, we are going to use r is 5g cos alpha as equation 2. Okay, and we can eliminate it and find the acceleration of B, and from here we can find out the acceleration. so that you can work it out. Is it making sense, guys? Guys, are you there? Year 13. Okay. Thank you, Kevin. Thank you, Rohan. Thank you. Okay, Anarthan. Thank you. Okay. Where's Sahel? Sahel. Inaya, you okay? Okay. Thank you, Sahel. Sahel, are you okay? Inaya? Okay. That's fine. So, thank you. Okay. So, this is what we have covered. What uh, uh, Thank you, Rohan. Questions. If you are liking the question, you might get one of these questions tomorrow. Sorry, on mechanics paper. Is that okay? So what I will do, I will start preparing your stats questions for tomorrow, and tomorrow we can late start around 8 o'clock. Will it be okay? It will be stats, guys. 8 p.m. is okay for tomorrow. Okay, okay. Okay, that's fine, guys. So that will be stats. Kavish is here or not? Kavish, are you there? Okay, that's fine. Okay, guys. So now we are going to end this session. It's been 1 hour, and tomorrow we spend 1 hour more on stats. Thank you. Bye bye. Bye bye. Bye, guys.